Hello again. This is Professor Lee. Today we are going to continue to investigate binomial distribution, right? And today we are going to learn how to use TI-84 for that calculation. All right. So as we know, TI-84 is a wonderful tool. It can do a lot of things, and that include this binomial distribution, right? So let's see. So how to access this binomial distribution? Now, as you can see from here, first we need to press the second and variable. So I'm going to show you how we do this, right? You got to turn this on. Let me clear the screen. So second half is right here, right? So I'm going to press, well, actually, let me share the calculator as well. Just a second. So there you go. You see this PowerPoint and this calculator, right? So as you can see, we are going to press the blue button right here, and then let me clear it. Second, and this VARS button, because what we really want is this blue writing right here, distribution. Remember, this is a binomial distribution, so we're going to press that. Then you see from this right here, you see these listing. Oh, here we have all these different distributions. Some of them we are actually going to use it later on. But for now, we're going to pull this arrow key down all the way to this binomial PDF. See the binomial PDF function. This is the one that we want. So we're going to press enter. Now, this is my previous numbers, so let me clear them. So they ask us to put few things. In first one, they want us to put this n value, the trials. That means we're going to put the total number of trial, which is the n value. And this p-value is actually p-value, which is probability of what? Probability of success, right? So this p-value is the probability of a success case. And this x value is out of n trial, x number of success case, right? X number of success case. And that's what we want, right? So, okay. Let's go to the next page. So remember that the game show problems that we checked in our last lecture. So we have, let's just quickly recap. 100 people are waiting to spin the wheel, right? 100 people waiting to spin the wheel. And out of 100, exactly 3 contestants will land on the goal. That's the probability that we are after. Out of 100 trials, so that means n is going to be 100, and we are looking for x number of success case. So x is going to be 3. But what about the probability of success for each trial? There are 36 slots, and only one of them is a gold. So P is going to be 1 out of 36, just like that, right? So let me actually go back. Let me put this random number and then get this result and clear. So if we want to put this, and from the last lecture, we knew that the answer was 0.225, but let's see how we can get this one. So again, what do we do? Second half and distribution, and move all the way down to binomial PDF. Remember that you also have binomial CDF. This is something different, which we will cover later. But for now, we are choosing binomial PDF function. So I'm going to put enter here. Now, number of trial n value is going to be what? 100, just like that, and enter. Now, the P, do I need to convert this to decimal and put it in? No, not really. You can just put it in as a fraction from 1 divided by 36, just like that, and enter. X supposed to be 3, and enter. And they say, do you want to calculate this? So I'm gonna put enter once again. Then they are confirming, is this the right n? Is this the right p? Is this the right x? So check it, correct, and put the answer. And there you go. That's it. That's the answer. I think this is a pretty amazing tool. Think about it. In our last lecture, we had to use this horrible looking formula, and we had to actually do all these factorials, and we need to put it in the exponent form. We had to do a lot of things, a lot of calculation to get to this answer. But if you use this calculator, all you really need to do is figuring out 3 variables, namely the n value, the p value, and the x value. N value, p value, the x value, and that's it. And you let calculator do all this complex calculation, and you get the answer just like this right away, right? All right. So is it that simple? Yeah, it's that simple, right? It's that simple. But I guess the difficult part is that we have to recognize this question as a binomial question. We have to recognize this question as a binomial question. I think that's the difficult part. But once you recognize this as a binomial, then later on, it shouldn't be. Using calculator and figuring out those variables shouldn't be too bad. So let's try this one right here. But I guess the difficult part is that we have to recognize this question, this question as a binomial question, because sometimes in most of the case, the question will not say, oh, use binomial. They will not say it. We have to figure it out, right? So let's try this. So it has been stated that 41% of adult workers have a high school diploma, but not pursued any further education, right? 41% of, adult workers have high school diploma, but they didn't want to continue further. So if you pick 20 adult worker, randomly selected, and what's the probability out of 20, exactly 12 of them have high school diploma but do not want to pursue any further education, right? That's the question. So let me recap. We know that 41% of adult worker who has high school diploma, but they don't want to pursue any further education, right? 41% have high school diploma, but they don't want to pursue any further. Now, if you pick 20 adult worker at random, what's the chance out of 20, exactly 12 of them, they have high school diploma, but they do not want to pursue any further education? What's the probability that out of 20, exactly 12 of them have high school diploma, but don't want to further study? Well, now, out of n trial, you look for X number of success. That's a typical binomial question, right? That's a typical binomial question. So just by looking at this question, this example, we should be able to say, oh, this must be a binomial case, right? We should be able to say, oh, this must be a binomial case just by looking at this question. Now, if it's a binomial case, then we need to figure out a few things. We need to figure out the n, we need to figure out p, we need to figure out the x. Now, what do you think? Let me give a little bit of time. Figure those out. Now, n should be total number of choice, which is 20. Now, out of n 20, p should be probability of success for each choice right here. So it's going to be 0.41. I mean, notice that we don't need to find the q, right? Because calculator can easily find the q, right? Just by doing 1 minus p. And x is exactly how many choice that we want out of this n. So out of 20, we want exactly 14 case. I mean, 12 case. What am I saying? Let me delete that. So 12 case, x should be 12, just like that. I mean, it's just right here, right? But still. So we want this binomial probability that the x value is equal to 12 case. That's what we want, right? We want the binomial probability that x value must be equal to 12 case. So how do we do this? Well, we can use the calculator again, right? We can use the calculator again. So let me rewrite it here. I mean, see here, right? N, P, and X value must be equal to 12. Right there. So we're going to turn it on. Where do I go? Second half, the VARS for distribution. Move it down all the way to binomial PDF. Enter. So n should be 20. Enter. P should be 0.41. Enter. X value must be 12. Enter. And enter again. So binomial PDF 20, 0.41, and 12. All right, so let's check it right there. So our answer for this question is going to be probability of x equal 12, which is what probability? If 20 adult worker randomly selected, what's the probability that out of 20, exactly 12 of them, they have high school diploma, but they don't want to pursue any further education? What's the probability of that? Well, 0.4173. So if you cut it, I guess right here, then that's going to be 0.417, or you can say 41.7%, like that. If the question said keep 3 decimal point, right? Just like that. Okay. Any question on this, right? Let me actually go to this one right there, right? Just like that. You go to binomial PDF. I mean, it's the exact same screen, right? And the exact same number, right? And I just showed you how to get there, right? Go to second F, go to distribution, VARS, move all the way down to binomial PDF and enter. Try 20. Yes, enter. P-value 0.41, enter. And X is 12, enter. And then just like that, right? So again, if we can recognize this example as, well, I mean, technically up to here, if we can recognize this example as a binomial example, then if you can figure out these 3 variables, then the actual calculation part is easy. You know now exactly what to do with this calculator, right? Go to second F and the variable, and then you go to binomial PDF and put all 3 variables, and that's it, right? So this is like relatively easy, right? Relatively easy. Right, once you recognize this variable and the general recognize this general type as a binomial, right? Now, this is similar but slightly different case. It's the same adult worker case, but as you can see, it's the same 41% that have high school diploma, but they don't want to do any further study. So P is the same, right? P is same, 0.41. And out of 20 adult workers, so this N is the same. N is 20 as well, right? Random selected. Find the probability, not exactly 12, but at most 12. At most 12. At most 12 meaning what? Out of 20, at most 12. That means out of 20, we are considering 0 case, 1 case, 2 case, 3 case, 4 case, all the way up to 12 case. This is at most 12 case. Up to 12, right? At most 12 means up to 12. That includes 12, right? Up to from 0 case, meaning like this. You ask that question, right, to the school, I mean, who has a high school diploma in working. Would you like to do a further study? And none of them says yes. I mean, 0 of them say they don't want to further study. 1 of them says they don't want to further study. 2 of them said they don't want to further study. All the way up to 12 of them says they don't want to further study. So in fact, you actually have to, technically speaking, calculate all these 13 cases, right? From 0 to 2, that 13 cases. And then you have to add them up, which will take all day, right? But this wonderful calculator of TI-83, 84, we can actually do this in one setting right here. So if the question says at most certain value X, what do we use? We use binomial CDF, see the CDF, instead of binomial PDF, we are going to use binomial CDF function. So if it's at most 12, that means the trial is the same, probability are the same, X value is the same, but this X value that we are using is not the PDF, but CDF, that cumulative. That C means cumulative, meaning all the way up to 12. So let's see. Clear this. Second half, distribution. Let's go all the way down to, oops, what happened? Again, I think I accidentally hit clear. Second half, variable, go all the way down to binomial CDF, this option right there. So I'm going to hit enter. Trials, same, enter. Probability, same, 0.41, enter. X value is also same, but we are not looking for exactly 12 case out of 20. We are looking for up to 12 case out of 20. So we're going to use binomial CDF. You can see right there, and enter, enter. It says CDF, confirm this variable, and hit enter right there. I mean, that's the same exact X value. I mean, the answer right there, right? So, you know, if the question says keep up to 4 decimal point, then you cut it right here. Since this is 8, that will change this 7 to 8. So we have this as our answer. If the question, I mean, it didn't really say in here, if the question says calculate up to 4 decimal points, and that's how you do it, and that's where you cut it, right? Okay, so let's go back. What's the difference between this question and, for example, if I go back to page number 5, this question? This is the original question. It says exactly 5. Oops, exactly 5 right there, right? Exactly 5. But in page 7, this question says, I mean, exactly 12. What am I saying? Exactly 12. On page number 5, right? Exactly 12. But in page 7, it says up to 12. At most 12. That means up to 12, right? Then you use binomial CDF instead of binomial PDF function, right? Okay. Now, look at this one. Find the mean and the standard deviation case for this question, right? This is a part of the question, right? This is the original. I mean, this is the big questions, and we have part A to find at most 12, and part B says find the mean and the standard deviation. Now, do you remember the formula for the mean and the standard deviation for binomial that we checked in our last class? I mean, it was pretty easy formula, right? Mean n times p. Variance, which is a sigma square, is n times p times q. And the standard deviation is square root of n times p times q. Remember, what was n? N was 20. Remember, p was 0.41. And then what's q going to be? Q is 1 minus p. So 1 minus 0.41 would be 0.59, right? Just like that. So first, for the mean, n 20 times 0.41, 8.4, right? And the standard deviation, because the question says find the mean and the standard. They didn't really say find the variance, right? So standard deviation should be square root n times p times q, right? So if you type this one up in the calculator, and that's what you are going to get, right? Let's confirm though. And let me show you how to do this. I mean, this mean is easy, right? 20 times 0.41, enter, 8.2, just like that. But what about this standard deviation? Where's the square root? I see square root right here, but it's in the blue, right above this x squared. So how do I get there? Second half and x squared. Then whatever that I'm typing, it's going to be inside. So 20 times. You see that square root sign extending, right? 0.41. Oops. 0.41 times 0.59 and enter. So I have 2.1995. So I guess they round it up, right? They round it up anywhere. They can round it up here. That changed that to 0. That changed that to 0. That changed that to 2. And that's how they got this number right there, right? Okay, so figuring out the mean and the standard deviation wasn't that big of a deal if you know the formula and how to type it in the calculator, right? Just like that. All right. So let me actually put this in full screen mode. Well, it doesn't really change much, right? So let me give you a little bit of time to try this example. I mean, I know that answer is right there, but why don't you just try this example on your own, and then you can check this answer. So try to figure out what's what, and what's n, what's x, and what's p, all that, and then try to put it in the calculator, and then see if you get the same answer. Right? Why don't you try it right now? Right? I can see who's doing, who's not doing, who's not letting me see, right? So, right, so please try this right now and see if you can get the same answer. Now, you know, all those TI-84 app that I shared with you last time, it does the same job, right? So you can try with whatever that you have. You can also try that 90-day trial, the software for TI-84, right, that I also shares with you. So make sure that you have access to this TI-84, right? Okay. So this question says, I mean, this is also the same question that we tried before, right? In our next lecture. 32% student participate outside volunteer program. That means P is going to be 0.32. If 30 students are selected at random, that means N is going to be 30, just like that. Find the probability that exactly 14 of them, that means X is going to be 14, just like that. So if we can figure out the N and the P and the X, then this is done. And It says exactly 14, exactly, that means what function? Binomial PDF function, not CDF, PDF function. So you go to second half, and variable. Pull this menu down to binomial PDF, enter, trial, N 30, enter, P 0.32, enter, X value 14, enter, and enter again. Verify this variable, press it, there you go. There's your answer right there, right? There's your answer right there. So if the question says keep 3 decimal point, that means you're gonna cut it right here, right? Since this is 8 bigger than 5, they'll change this 5 to 6. And that's why we got this answer right here, right? So let me give a little bit of time to recap. The p-value, the n value, and the x value. And because it's set exactly, we're going to use binomial PDF function, right? Binomial PDF function. And then just use calculator to get to this answer. Just like that, right? Okay, so it wasn't too bad. All right, this is another set of questions. It has many parts, A, B, C, D, all these different parts. So this Gallup organization found that 45% of adult Americans believe that overall state of moral values in American state is poor. I mean, 45% of adult believe that something's not really right about the morale of this country. Okay, so question A, find the mean and the standard deviation. Meaning find the n, find the p, find the q, and put it in the formula. N, out of how many? Out of 500. So n is going to be 500. P, probability of success for each case, right here, 0.45. Q, remember Q is 1 minus P, which is 1 minus 0.45, which is 0.55. So we have the P and the Q and the R and the N. So it's just to figure out this mu, right? N times P, I mean 500 times 0.45. Just like that, we got 225. And the second part, square root, right? Right here. So second half, square root 500 times 0.45 times 0.55 and enter right there, right? So I guess this one you keep 2 decimal point, so that's smaller than 5, so you just drop it, and that's the answer right there, right? All right, so figuring out the mean wasn't that bad. Now they say, same question, same 45% American adults believe that state of morale of this country is poor. And the next question says, would it be unusual that to identify 240 adults believe that overall state of morale of this country is poor. If you ask 500 people, right? If you ask this question to 500 people, would it be unusual that out of 500 adult, about half, right? About 240 of them will say, you know, something wrong with this country, morale of this country. Would it be unusual to get 240 respond out of 500 American adult? And that's the question here. That's the question. Would it be unusual? I mean, who would know which one is usual, which one is unusual? Well, see, for the usual, unusual, we gotta follow this formula. We're gonna follow this formula for the usual, unusual values. So first, we need to find this interval of minimum value and the maximum value. How do you set the minimum value? Mu minus 2 times the sigma. And the maximum value would be mu times 2 times the sigma. What was our mu value? I mean, it's still here, right? It's still here. 225. What was our standard deviation value? 11.12, right here, right? So let's use these two values to put it in there. So let me actually clear this. So to figure out this, mu value is, because I'm trying to put this right here, 225 minus 2 times 11.12, and hit enter. And that's this minimum value. The maximum value is similar, 225 plus 2 times 11.12, and that's the maximum value. So that will set up this interval as 202.76 and 247.24. Now, this given value, 240, is it between this interval or is it outside of this interval? If this value is within this interval, then this is usual response. But if this given value is outside of this interval, if it's not within this interval, then we call that unusual. So what do you think? Well, 240 is between these two numbers. So this is usual case, not unusual case, right? This is a usual case, but not unusual case. I mean, it says it right here, right? They give you the actual calculation, right? All those values that we just did right here, right? 202, 76, 247, 24, right there. And this is between these two values, so this is not unusual, or you can just say usual, same deal. Okay. Now, 14. Now, this is another question. Let's say 35% missed the school because of the asthma, right? Research company says, out of all those people who's missing school, 39%, did I say 39% actually missed school due to the asthma. Okay, so if a group of 10 school children are randomly selected, right? What's the probability that out of 10, exactly 8 of them will miss school because of the asthma? Now, remember, it says exactly X number. That means what do we use? We use binomial PDF. Binomial PDF. Then what's our N? Total number of trial? 10, right? Because 10 school children are selected at random. What's our P? P is given right here, 0.39%. So it's going to be 0.39. What about X? How many? Exactly 8 of them. And we put it in the binomial PDF. So clear. Go to second half and distribution. Go to binomial PDF. And then trial is going to be 10. Enter. Probability is going to be 0.39. Enter. Out of 10, 8 of them. Enter and enter. Check these value and enter. And that's our answer right there. And since we cut it, and it says like write your answer in 4 decimal places. So we are going to cut it right here. Since this is 6, they'll change that to one bigger number. But since this is 9, they'll change 0. They'll change this 8 to 9. And that's why we have this answer right there, right? Okay. What about this next question? It says at most 7, not exactly 7, but at most 7. Remember that at most case, right? At most means what? At most X, then we are going to use binomial CDF function, right? Binomial CDF function. So same deal, right? Go to distribution. Binomial CDF right here. Enter. The total N, 10. Enter. P, 0.39. Enter. X, at most 7. That's exactly same thing as putting 7 right there. Enter, enter, and enter. Okay, it says write answer in 4 decimal places again. So we are going to cut it right here. Since this is 8, they'll change that 6 to 7. And that's what we get right there. Right? That's what we get right there. Okay. Next one, we are almost there, right? Now, this one says the same question, same 39%, and we are selecting 10 children, but this one says not at most 5, it says at least 5. So how do you deal with the at least certain number question? Well, I wrote it right here. At least X is the same thing as 1 minus at most X minus 1, one smaller than this. So if it's like at least 5, then we gotta do 1 minus, find the probability of at most 4, right? If this is at least 5, then we got to do 1 minus at most 4. So how do you find at most 4? Remember that at most 4 is what? Binomial CDF, right? Binomial CDF. Right? Since we've done it many times, I'm not going to repeat this, right? The process. Binomial CDF, you put trial right here, the P and the X. You cut it, and this is what you get. So that's at most for this part right there. But that's not the main question. Main question is finding this, at least 5. So we gotta do 1 minus whatever this value that we get. Then that's our answer right there. So let's recap. Try to figure out at least some value. We need to find 1 minus and most 1 less value than this x. Why do we need to make this conversion? Because calculator does have this at most 4 function, which is binomial CDF. So to figure out at most 4, you can use binomial CDF function, and you can get your answer right there, right? So once you get your answer right here, you do 1 minus of that value and most 4, then you get your final answer, which is what you really want, which is at least 5 case, just like that. All right. Okay. What about this one? It says no more than, I'm not more than 3 children out of 10, more than 3 children. So how do you deal with the more than certain number x? Well, you do 1 minus at most this same value right here, 1 minus at most. So if you want to find probability of more than 3, then you do 1 minus at most 3. Now, why are we keep using this at most certain value? Because at most certain value is binomial CDF function. Remember that CDF function. So this is what we really want, because that's what the question is asking. But we cannot directly find this value from the calculator. We need to find at most 3 first, like we do right here, and then do 1 minus of that value right here. And that's our final answer that we are looking for. Right? That's the final answer that we are looking for. So more than certain x value, we use this format, 1 minus n most x. Okay. All right. What about this? What if the question says find less than 6? How do you find less than 6? Well, less than x is going to be same thing as at most x minus 1. So figuring out less than 6 right here, that's the same thing as figuring out at most 5. At most 5. Now, we know how to find at most 5. That's a binomial CDF function. So you just need to put these values, right? Well, let's just try this. So let's see. Turn it on. Go to second half. Distribution. Looking for distribution. Looking for binomial CDF for n most 5, right? Enter. It's going to be 10. Enter. 0.39, enter. But the x value is going to be 5, right? Remember, that's going to be 5. 5, enter, enter, and enter. Okay, right here. So it says right up to 4 decimal. So we are going to cut it right here. But since this is 9, which will add 1 to this 9, which will make this to 0, which will make that 4 to 5. And that's our final answer right there, right? All right. And for the final question here, we need to figure out, this is relatively easy, right? Find the mean and the standard deviation. So mean, we know it's n times p. Standard deviation, square root of n times p times q, or 1 minus p, same thing. Q and 1 minus p are the same thing, remember? Right? So we can, let me show you. For the mean, that's easy, right? 10 times 0.39, 3.9. The second half, square root 10 times 0.39 times, I mean, I can write it exactly same like this. Open it up, 1 minus 0.9 and close and enter. Same thing. It says 1 decimal place. So we're going to cut it right here, drop the 4. It's just going to be 1.5, just like that, right? So we did a lot of stuff, right? We did, let's go back, usual, unusual, right? By setting it up, let me go back to here. We did binomial PDF for exactly certain number of x. At most certain value, we use binomial CDF, as you can see from here, right? And we did also the usual, unusual. How to find the usual, unusual? You have to find this, you have to follow these steps in red. Find the minimum, maximum value, right? And then exactly 8, you use binomial PDF. At most certain value, you use binomial CDF. If it's at least certain value, you do 1 minus, at most, that value minus 1. So if it's 5, it's going to be 1 minus, at most 4. If it's more than, then you do 1 minus, at most, same value. And if it's a less than, it's going to be at most 1 less than that x value. So it's going to be less than 6, then at most 5, right? And then we did this too. So, you know, this could be a little bit confusing, but like I said, I'm going to keep the same format. It's not going to be any different from, you know, one of these questions. It'll be same format. And with the calculator, hopefully this will be manageable for you. All right, so that's the wrap for this lecture.